Example 4. Water runs into a conical tank at the rate of 9 cubic feet per minute. The tank has a height of 10 feet and a base radius of 5 feet. How fast is the water rising when the water is 6 feet deep? So first, let's start highlighting some important information that we think we're going to need. So water runs into a conical tank at a rate of 9 cubic feet per minute. So then this is our volume. So this is going to be dV dt. The tank has a height of 10 and a base radius of 5. Right away we know that h equals 10 and r is going to equal 5. And then how fast is the water rising when it's 6 feet deep? So we know then this is another h of 6, and this means how fast, so we're going to look for a rate. How fast is the water rising? So we're going to be looking at how fast the height is changing. So we're looking for dH dt. That's the goal. So step 1 is to draw a picture. So this is going to be a cone. So there it is. And you can draw it that way, or you can draw it with the pointy end up. It doesn't really matter for the sake of our example. We know that the radius of this cone is 5, and we know that the height of this cone is 10. So we want to know when the water is 6 feet deep, so when we are about right here, when this is 6 feet, we want to know how fast is the water rising at this moment. So first, let's start by identifying what do we know. What do we know? Well, we know that the radius is equal to 5. We know the height that we want at the moment is 6. I'm going to write at moment next to it. This symbolizes that this is the height that I'm going to want. And then we also know that dV dt, the rate at which the volume changes, is 9 cubic feet per minute. And then the question is, what do we want to know? And what we want to know is the rate that the water rises, which is going to be dH dt. It's the rate that the height is changing. So we're going to need some equations. So what do we know about the volume of a cone? Well, we know the volume of a cone is 1/3 pi r squared h. Well, if we look, we have volume, we have radius, and we have height. Well, the problem is that we don't know anything about the radius at this time. We know that when the cone is full, it's 5, but I don't know the radius when it's right here, and that's the problem. But if you look closely, we can figure that out by using similar triangles. So we're going to use what we know about similar triangles. So if you look, I have a big triangle, where this is 5 and this is 10. And then I have a smaller triangle where this is h and this is r. Now what we're going to do is use what we know about similar triangles. And we're going to say 5/10 is equal to r over h. Now in my formula, I only want to have h's because I don't know anything about the radius. All I know is that h is equal to 6. So I'm going to get r by itself over here. So I get 1/2 equals r over h. So r is equal to h over 2. So what I'm going to do with that is I'm going to take that and I'm going to plug it in right up here. So I get volume is equal to 1/3 pi h over 2 squared times h. So volume is 1/3 pi h squared over 4 times h. So volume is pi over 12 h cubed. Now I've got it in two variables, so now I can go ahead and solve. So I'm going to take the derivative with respect to time to both sides. And I'm going to get that dv dt is equal to pi over 12 times 3h squared dh dt. And from here I'm going to do a little simplifying. dv dt is equal to pi over 4 h squared times dh dt. Now remember, this is what I'm looking for. So I'm going to go ahead and plug in the values I know. I know that the water is increasing at 9 cubic feet per second. So I get that this is going to be 9 is equal to pi over 4. I want it when the height is 6, so 6 squared dHdt. And I get 9 is equal to 36 pi over 4 dH dt. 9 is equal to 9 pi dH dt. So dH dt is equal to 1 over pi. This means that the height is changing at approximately 0.318 feet per minute. That's all the calculus we have to do. So now we're going to write the summary. And we get that the water is rising at 0.318 feet per minute when h is equal to 6 feet. And that's it.